Hello, my name is Lee Presser. This is my show. I speak frequently to very interesting people. Some of these conversations are so exciting, so intellectually stimulating, I thought others might like to listen in. This is the reason we started recording Conversation with Lee Presser.
Welcome to Conversation with Lee Presser. Meteorologists are scientists who study that branch of science concerned with the processes and phenomena of Earth's atmosphere. Meteorologists work in government agencies, private consulting firms, research services, utilities, educational institutions, and at radio and television stations. Many radio and television weather forecasters are professional meteorologists, while others are merely reporters with no formal meteorological training. Our guest today comes with the seal of approval from the American Meteorological Society. He is the Fox2 Emmy Award winning weatherman Chris Higgins. Mr. Higgins is a 1992 graduate of St. Louis University, where he studied meteorology. In 2006, he became the first ever St. Louis meteorologist to receive the American Meteorological Society's Certified Broadcast Meteorologist designation by passing a rigorous written test covering many aspects of atmospheric and natural sciences. He's here today to discuss what it's like being a TV meteorologist in a large market television station. Chris Higgins, welcome to the conversation.
My pleasure. Thanks for having me.
You've been doing that a long time now, haven't you?
22 years here in St. Louis, and then 2 years before that down in Joplin, Missouri, where I started.
And before that, you did some intern work.
I did.
Too. Were you on air, or that was
No.
just?
I actually interned here in St. Louis. I'm from St. Louis. I'm a local boy. Grew up in town, and I interned at Channel 2 with Dave Murray, a much younger Dave Murray at the time. And interned with him when I was at St. Louis University. So that sort of set the stage for me to maybe come back later on down the road.
Mm-hmm. And you're DeSmet?
DeSmet Jesuit High School grad. Just found out my 14-year-old son, is going to be attending there next year. So the tradition continues. But
congrats.
Yeah, local boy all the way through.
There you go. So, all right, like I said in the intro, let's talk a little bit about what's it like, because most people, they just turn on the TV and they don't, they just think of it as fun. Now television news has become fun and games. It didn't when you started there,
right.
and years ago when I was there, it was much like Max Roby was much more
right.
formal set.
What we've learned over the years is, and people's attention span has dwindled over time with the advent of mobile devices and video games and things of that nature, but generally people's attention span is not what it used to be. So we have to try and liven it up a little bit to keep people's interest going. It is challenging sometimes. It's challenging all the time. It's fun to be a forecaster and always have to deal, when I come into work, with a different set of problems from Mother Nature, trying to figure out what's going to happen today, tonight, tomorrow, the next day, and beyond. The technology has improved, but strangely enough, as the technology has improved, the difficulty level has increased as well. And so is the expectation from the general public as far as how far out they want us to forecast and what they want us to forecast and with what specificity, how many details they want in the forecast. But it really is, it's an enjoyable job most of the time, because every day it's a whole new ball game for the most part. And we, of course, get all 4 seasons here in St. Louis, which makes it that much more enjoyable.
How do you answer those people who say that, oh man, a job where 50% of the time you can be wrong and you still don't get fired?
First of all, we're right about 90 to 95% of the time. Second of all, if Albert Pujols got 50%, was hitting 500, 50%, he'd be getting even more money. So our batting average is a lot better than Albert Pujols, who we all know makes a whole heck of a lot more money. So.
Yes, he does. So what's the process? You come in, like you say, are you spending time when you're away from the station?
Absolutely.
You're on your computer, you're looking at what?
It's 24/7, really is. To be a good forecaster now, because we do so much non-weather stuff behind the scenes at the TV station, between promotional stuff, public appearances, and things like that. We don't have nearly the amount of time to dig into a forecast actually in the office as we would like. It is really around the clock work from home via the internet, software packages. There are apps on your phone that you can get. I can do a lot of my forecasting now just on my iPad or my cell phone that in the old days, my original days, I would have had to have been in the station to do. So it is a 24/7 observation and then forecast.
Well, what
always
exactly are you doing? What are you looking at?
I'm looking at wind patterns, temperatures, and it's not just here in the bi-state area. It is all across the country for short-term trends. What's going to happen today, tonight,
What's the
tomorrow.
Pacific Ocean? I've noticed that you and Dave Murray, you're always looking over to the Pacific.
Well, that's where our weather comes from.
Okay, all right.
That's
Explain that to me.
The land-ocean system, as we call it, it's actually land-ocean-air system, is what makes up our atmosphere, and really essentially
In North America.
everywhere. I mean, now our weather is primarily affected by North American, land, sea, ocean interaction, but they are all inner workings together. You cannot take one out and just ignore it because it affects the other. The one that you're talking about, the Pacific Ocean in particular, right now we're getting ready to go into what appears to be a very strong El Nino pattern.
Now, what is that?
El Nino is an unusual warming of the water in the central Pacific in a region east of the dateline, probably about 2/3 of the way across the Pacific in equatorial areas between essentially the equator up to about 30 degrees north. When it gets unusually warm in the water down there, which happens every 2 to 7 years or so, that warmth is energy, and it gets translated up. Warmer air leads to more clouds, bigger thunderstorms that conglomerate into big clusters, actually add energy to the upper levels of the atmosphere, change the jet stream, which is the river of air that drives big air mass changes and also big storm systems. So normally, if there is a normal, really, what we're finding there really isn't a normal, it's more of an oscillation. But when there is no warming water down there, the jet stream tends to be further north going across the Pacific and then dive south over the U.S., which allows cold air to pour off the North Pole. But when the jet stream builds because of this El Nino further south, the North Pole is cut off. We tend to be warmer, especially during the winter months, and we have a more direct pipeline of Pacific moisture, which should, in parts southeastern third to 2/3 of the country, should lead to wetter conditions. I say should because not every El Nino is the same, and that's the beauty of weather, what makes it interesting. You can't just go off repeating patterns. Each pattern, even though it repeats, is a little different.
Yeah, well, St. Louis has been unusually dry for a couple of years. We had that one really wet period,
Right.
and then all of a sudden, boom, it was cold. I forget, it was like just a couple summers ago. I remember it was like June was like frigid almost, and then all of a sudden, I think it was in July,
It got very, very warm.
and it stopped raining.
Right.
And that was it. And it didn't rain, I think, basically for the rest of that year. I mean, not entirely, but didn't. And then the next spring we had a little bit of rain, and then it stopped again.
We've had very dry summers.
So what's going on?
We're in a bit of a drought pattern, especially west of St. Louis. We've been right on the edge. There was one short period where we were exceptionally dry. We really were in pure severe drought conditions. That was most of last summer. We were really, really dry. The year before that, we had some drought conditions. That was the year we actually hit some of the highest temperatures we've had in decades when we were up 107, 108 degrees.
Yes.
With the extreme heat. Dry, hot air breeds dry, hot air. That's one thing, a pattern that we do follow very frequently is when in drought, forecast drought until it rains. And the weather charts can all suggest that it's going to rain, but until you get a drought-busting rain that actually occurs, you always, as a forecaster, downplay any chance of rain until it actually rains, because inevitably what happens is the dry ground and the hot air sucks the moisture out that looks like it's coming our way, and it ends up, it's a perpetual cycle. It's a feedback mechanism. The drier and hotter it gets, the drier and hotter it gets, because dry air
also,
warms
the reverse
faster.
is true too.
Yes.
When it rains a lot,
Yes.
that creates more rain.
It does. What happens, because you pour the rain down in one area, and now the ground's wet. Soil's saturated, and instead of having to look down to the Gulf of Mexico to get a moist flow from the south, for us to get big rains around here, we have to have a southerly wind coming across the Gulf of Mexico to transport that moisture up here to turn it into clouds. But when we've already had a lot of moisture, we no longer have to rely solely on the Gulf of Mexico. So a system that would normally need to suck moisture out of the Gulf of Mexico doesn't have to do it anymore. It's got its own supply here, so the moisture gets evaporated out of the crops and the ground, goes up into the clouds, and turns right back around. comes down.
And we've had that happen.
Yes.
A number of times.
2008 was probably the best recent example of severe flooding.
93,
93 was the biggest, right. 93, 94, 90. There was that stretch from 93 through 96 where a couple of times we had the record in 93 on the Mississippi for flooding, but then again in 94 and I think again in 96, we were flirting with that record level again.
Mm-hmm. So we talked about El Nino. Mm-hmm. So La Nina is what, the opposite?
It's the opposite.
The cooling?
Yeah, the cooling of the Pacific waters. And that has a different effect. If it's cooler than normal, again, the jet stream tends to disappear. There's no energy transfer between the water and the atmosphere down there. So the jet stream storm track pattern, if you will, shifts much further to the north. And then it comes up towards Alaska. Now, usually that might result in warmer temperatures in Alaska because of the way the jet stream kind of pivots and actually points into Alaska initially, which warms their temperature up, but then it curls down into the Midwest. La Ninas can be pretty tough to call here because we're right on the line between much colder or near normal temperatures, but it's usually drier around here during a La Nina.
Now, during this year, 2014, when it was like freezing cold, by freezing cold, I mean minus.
Right.
It was pretty cold to be outside. I was looking at Ketchikan, Alaska weather, and they were in the 40s.
Yep, and
that's Alaska.
That's what happens. If it's warm in Alaska in the winter, you can pretty well bet it's going to be really cold here because that's when the warm air builds up into Alaska, it dislodges that cold air and it has to go somewhere. Most of the time it's like a seesaw. You seesaw it up, the temperatures go up. In Alaska, the cold air has to go somewhere, and it usually pivots down the continent into the Midwest, east of the Rockies.
So coming all the way back to the process, you spend your day and nights looking at computers, at models of weather that's out to the west of us to see what's coming towards us. I guess I don't understand that's why I'm not a meteorologist, is I don't understand that magic of what it is that you see in your mind, because you see it in your mind, don't you? I mean, it's like you see numbers and then all of a sudden it's like, okay, that translates to this sort of weather.
The process is a lot like being a doctor. When you go and see the doctor and or the nurse the first thing they're going to do is assess your current condition. What is your current state? What are your vital signs? Your blood pressure, your breathing, your temperature, etc. We do the same thing with the atmosphere. On a daily basis, the first part of the forecast is to assess the vital signs of right now. What's going on in the atmosphere? We use the same gadget. We take our temperature, stick a thermometer in our mouth. Weather guys, we send it out the window to see what the temperature is. Mm-hmm. We check breathing of the atmosphere by monitoring winds. If you break your arm, the doctor's going to do an x-ray. We have a satellite to look at clouds. We look inside the clouds with radar. We're trying to figure out what the current state of the atmosphere is right now. Then, and this is the important part of the forecast, we use our experience. We use the computer models. Computer models are only guidance, though. It's a lot of math that points us in a general direction. But the problem with the computer models is they don't have enough computing power to possibly deal with all the interactions between the land, ocean, and air. So it's just an estimate. It kind of gets us in the neighborhood. So this is where we fall back on experience. And there is no substitute for experience. I like to look at forecasting. It's maybe 50% looking at models to get an idea of what's going on in current conditions. It's 30% experience, at least 30% experience to be able to have, hey, I've seen this before. I know I've got that gut instinct. And then, of course, there's about 10% luck where you get it right just for the wrong reasons, and you just walk away and say thank you very much.
Now, Dave Murray does his quarterly long-range forecasts, which I suspect are difficult to do.
Yes.
But he talks about a number of elements in this, but he also talks about looking for patterns from, I guess, decades ago, because he just recently mentioned the 50s and the 70s when talking about this past winter. Analogs.
Analog years.
That's the word that he's using. He also mentioned, so I'd like you to comment on that, but he also said that in his opinion, he's been saying this for a couple of years, that winters, and he was, a couple of years ago saying winters are going to get colder in St. Louis. What is it you guys see that say that, and then it becomes true?
We'll start with analogs. Analogs is simply a way to quantify experience. In our experience, and now with the computing power we do have, we can take prior year weather patterns, wind patterns, and drop them into a computer and look back more freely, rather than just saying, gosh, I kind of remember this pattern. Now we can go back to a computer and say, yeah, this was the weather pattern back in the 30s, 40s, 50s, or whatever, and we can run and look at it and say, you know what, this is similar to what we had preceding the cold winters of the 70s or the 50s and 40s or what have you. And then we say, because the Earth tends to be cyclical, you have spring, summer, winter, fall happens every year. Weather patterns do tend to be cyclical, even if the specifics are a little different. We can say with some certainty that that pattern then led to this, then this same pattern roughly now probably is going to trend in the same direction. So that's what analog means. It's just looking back off experience, but also in reality.
A set of circumstances.
Right. And it's a lot, what a doctor does. The doctor's going to look at you. If you come in with a cough and a red throat and a runny nose, they might look at you and you're running a temperature. They don't have to swab you, to do all that. They say, you have the flu, all right, or you have a cold. And that's their experience talking. They're using an analog based on prior experience. That's what we do with weather. We use an analog. Okay, based on prior experience, this is what we think is roughly going to happen. Now you get into the patterns as far as forecasting the extremes. There's a whole lot of work that still needs to be done on this as far as the exact details. Dave has been talking about colder and colder winters for a while now, and part of that has to do with solar cycle. We're in a part of the solar cycle right now, which is an 11-year process of increased sun flare activity, sunspots, and decreased. Well, we're in a
cold period.
Right, we're in a cold period right now, which if you follow the solar cycle on a calendar over the years, there's definitely an effect on our weather across the entire world, for that matter. So there are implications for that, and that's one of the reasons we're trending downward a bit. There are other inputs into that, though, that are different than years past. You have to look at the amount of ice that is no longer on the polar ice cap up in the North Pole, which has not totally melted off, but it's at its lowest amount of ice in many, many, many years. You've got Greenland, the ice sheet there melting off as well. So there are changes that are different than we had, say, 30, 40 years ago. My contention is that with less ice on the polar ice caps, it seems backwards, but we're going to end up with more cold air in the continental United States during the winters, because when the warmer air is located off the coast and gets further north, that forces the cold air to confine itself to where it's colder. So there's going to be more snow over the land areas over Canada down into the U.S., and that's where the cold air is going to tend to want to gather and collect, versus over the North Pole, where it's not as ice covered as it once used to be.
And how long does that go on? I mean, are we talking years or decades?
I don't know. I really don't. That's just a theory of mine. I haven't tested it. Although this year was a pretty good test and worked out pretty well. It has been very, very cold. I think that Dave's probably on the right track, at least in the short term. But beyond that, we can run all the modeling that we want to.
And then the Earth will do what it'll do.
And then the Earth's going to do what it can do. We do not, as much as we like to think we know what drives the atmosphere, there's still so much that we don't know that I just don't think that we really have a clue. I think we have a clue, but I don't think we have much of a good idea.
Yeah, I always do a lot of research before my guests come in, and so I'm reading about the Earth actually at the poles does this thing. I forget what it's called.
It wobbles. I mean, 23 and a half degrees back and forth between.
But it goes around, and that makes a difference. And then apparently there's some gravitational differences between the Earth and the Moon, which causes, and all of this tends to have an impact on weather on planet Earth.
There's also another one that nobody really thinks about, and that is that the Earth's orbit around the sun is elliptical. Right now, at this point in our Earth history, our summers are at the furthest point from the sun. So summers are technically cooler than they could be if we were closer to the sun at summer.
Oh, when the Earth
when the
is,
elliptical,
right? When we're pointing in the opposite direction,
right? We're actually at a
be
good
hot.
time because and it changes that
Right.
process
Over
orbit.
23,000 years.
It's a long process. But at some point, the Earth will be closer to the sun in summer and further away at winter. And when that happens, boy, are those summers going to be hot, and boy, are those winters going to be cold.
Right. Sometimes when I listen to people on television talking about the weather, who are not meteorologists or climatologists, they're just talking, they just seem to, they just want to make all these scientific assertions based upon, and I'm not quite sure what it is that they're making these assertions on, which I guess brings us to, what is the difference between a climatologist and a meteorologist?
A meteorologist, now meteorologists can be climatologists, but they have to study. It's a whole different science. Just because you're a meteorologist does not make you an expert on climate, and just because you're an expert on climate doesn't mean you're an expert on meteorology. Climate is the whole world, weather patterns, long-term involvement of the land-sea interaction and how it changes over time. Meteorology is more of the day-to-day, what's going to form a severe thunderstorm, what's going to form a heavy snowstorm.
It's going to be 60 on Tuesday.
Right. We're more concerned about the short-term, finer scale inner workings of the atmosphere. Climatologist is much bigger picture, looking at broader implications, and is much more involved in the land-ocean interaction, and gets, as far as not just top of the water, but down deep in the water. I mean, there's so much more involved there. I know about that much climatology. I know enough, as most meteorologists do, to talk about it, but we are not, most meteorologists, climatologists. And I think that's something that viewers and the public generally needs to understand, is just because somebody is a meteorologist, they are not necessarily a climate expert.
Okay.
It's the second part of your question, which I don't even remember now.
Well, actually, I wanted to move on to, you're a graduate of St. Louis University. What is it called? The
Earth and Atmospheric Science.
There it goes.
Yeah.
And maybe you met Ben Abel?
Oh, yeah, I've met Ben, Chief, as we used to call him.
Yes. But what I'm really asking is, for those people who are watching, maybe young people or even their parents, if somebody wants to become a meteorologist and they're still like in high school now, what is it they should be focusing on, and what do they do to get to the right school, and what do they need to be studying and working on right now?
Math. I have a Bachelor of Science in Earth and Atmospheric Sciences, and if I was really motivated at the time, if I had taken one more math course, I would have had a math degree. That's how much math there is. I have more math stuck in here than I probably ever use.
Why math?
Because Earth science and the atmosphere is all the movement. It's essentially fluid dynamics is what it is. And all of that motion is described by mathematical equations. It's the same kind of stuff that they use to build airplanes. The fluid dynamics of airflow over the wing, of how that keeps the airplane in the air, or it's all that is described, all the curves, all the motions, the densities, and the interrelationships is designed with very high order differential equations. You have to understand how that works before you can understand how the atmosphere works. Now, do I use that specific math and hand jam equations every day? No. There are people that do that in the research community, but in the forecast community, where we're taking research and applying it, you have to understand what's behind the math so that you understand what the inputs are in the atmosphere.
So math is a big one that people...
It's probably the biggest.
The biggest.
Yeah.
What about computer programming? Do they need to know that?
I took some Fortran. For your viewers who may or may not even remember what that is, yes. I don't even think it still uses.
It's a scientific program.
Yeah. Computer science is still very important, especially if you're going to go into the research side of things. If you are trying to jam numbers and qualitatively figure out statistics, for instance, then yes. I don't, other than that one course, I don't have any formal computer science training. It would be beneficial if I were in a research environment. Then I would probably go back and get more computer science. So it really depends on which angle you're going to end up with. I knew pretty early on that I wanted to go into applied and operational meteorology. and that's which is where I'm at. I like being down and dirty in the trenches. I'm not a very academic person.
So a lot of math, and then work your way towards going to SLU or some other university.
Exactly. And you know, the benefit now over when I was a kid was we have the internet now. You can get anything on the internet. There's so much good material that youngsters, teenage high school kids can get their hands on to wet their whistle and get them involved and interested. And you don't have to get into the higher order math stuff on your own, but there's some great modules online that are put out by the National Weather Service that are very helpful to educate and kind of get kids interested in more of the background of it. It's not just sunshine and blue cold fronts and red warm fronts and little smiley face sunshines. There's a lot more into it. And the particular one that I like for kids to look at is it's a module on the Weather Service websites that's called Jetstream. And it's just an online classroom, and it really gets into the inner workings of the atmosphere, but at a level that most grade school and high school kids would be more likely to understand.
In the last couple of minutes that we have here, what is the relationship between the National Weather Service and television?
It's very good, at least in this market. It's different everywhere you go. There are different relationships in different places. I can only speak to what I know here, and the relationship is exceptionally strong. It was not always that way. I've worked tirelessly with my friends who have come into the National Weather Service over the years to grow a very strong partnership, and I would venture to say that the partnership we have in local media, and it's not just Channel 2, it's Channel 4 and 5, Channel 11, all of us that we have with the National Weather Service and vice versa here in the St. Louis area is as strong as any in the country, and maybe the model for the country. We have outstanding communication with them and coordination on major weather events. We frequently, in fact, just this past weekend, the Weather Service had all of us out, all the TV folks out, for a spring weather refresher seminar on spring weather forecasting challenges. And we all sat down and went through some prior case studies and events from years past that we've all been through, just to get them, wake us up and say, hey, spring, even though it doesn't feel like it outside, no, spring's coming. Spring will be here before we know it. Spring storms, and that's something you always have to do every season. You have to refresh your memory on forecasting for the season.
Well, last night on the March 24th, it snowed.
Yes,
not bad, but some. This isn't completely wacky, is it? I mean, some people are like, oh my God, the weather's just completely changed.
Our biggest snows are very often in the month of March. Just look back to last year, 2013.
Right.
We had like 18 inches of snow in some parts of the metro on the last day of March, on Palm Sunday. And that was like a few days before it was 85 degrees. That is the beauty of March. Snow doesn't last very long this time of year. But March can be very volatile.
That's about all the time we got. You know about time. Thank you very much for being with us. Certainly do appreciate your taking the time to come over here.
My pleasure.
I've been speaking with Chris Higgins. He's the Fox2 meteorologist, been there for 22 years. If you watch television in the St. Louis market, you probably have seen him many, many, many times. I want to thank you for being with us. We're going to be uploading this to YouTube, so if you didn't catch it all, just go take a look at YouTube. You can see the rest. Thank you very much. See you next time.